In this video, gears and a wheel are added to the gearbox housing which was created in previous videos. The gears are mated with each other mechanically, making this a fully working simulation of a real gearbox. Assembling the gearbox in this way allows you to check that everything fits together properly with no collisions before it is sent off for production. Let's get started. To begin, browse to the part named Gear 18 and add it to the assembly. This is the first gear which attaches directly to the motor shaft. The gear needs to be mated concentrically with the motor shaft. If you do not know how to do concentric mates, please refer to the previous video. The gear is now concentrically mated, but it is not fully constrained and it is free to move up and down. The gear wants to sit at the end of the shaft, so mate this ring around the shaft with the outside face of the gear. Mate them using the coincident mate. Again, if you do not know how to do this, please refer to the previous video. Let's add the second gear. Browse to the file named Gear 4612 and add it to the assembly. Same as before, concentrically mate the gear, but this time with the second shaft. Again, mate the ring around the end of the axle with the outside face of the gear to force the gear to the end of the shaft. The second gear is now attached to the end of the shaft, but as can be seen, the shaft is free to move in space. The gears need to be in perfect alignment so they mesh properly with each other. To do this, select the two outside faces of the gears and mate them using the coincident mate. The last gear in this example has the same number of teeth as the second one, so again, browse to and insert the part named Gear 4612. Mate it concentrically with the last axle. This time the gear doesn't need to be mated with the end of the shaft, as the wheel will go there. It needs to be aligned with the second gear though, so select the back face of the last gear and mate it with the coincident mate to the front face of the second gear. The gears are all now in alignment, but the teeth are not meshing properly, and the gears are allowed to spin freely. To mesh the gears, a gear mate is needed. To add a gear mate, select Mate from the Assembly tab, and then browse down to Mechanical Mates. Unselect any faces currently selected if the gear mate is greyed out. Select the gear mate, and then select the blue box to tell Solidworks that we are ready to choose our faces. Select the outside face of any tooth on the first gear, and then select the inside face of any tooth on the second gear. The ratio numbers needed to be entered into these boxes is half whatever the number of teeth there are on the gears. So as the first gear is an 18 tooth gear, we enter 9 in the first box, and as the second gear is a 46 tooth gear, we write 23 in the second box. Make sure reverse is selected. Press the green tick to complete it, and then test the gear mate by moving the gears with your mouse. They should mesh together perfectly. If they don't, check the ratio numbers and redo the mate. Now that the first gear mate is complete, it's time to make the last gear. To do this, select Mate and again browse down to Mechanical Mates and select Gear Mate. Select the outside edge and inside edge of the two teeth that you wish to mate. It doesn't matter which order you select them as long as the ratios are correctly set up. The inside gear has 12 teeth, so we enter 6 in the ratio box, half that, and then the outside gear again needs to be 23mm. This time the gears are going in the same direction, so deselect reverse. Check that the two gears are meshing together properly, and if not, check the ratios. Move the first gear with the mouse and make sure that the last gear is moving correctly. The last shaft needs to be aligned with the back of the plate, so coincident mate it with the back face. Notice how moving the shaft does not move the gears. This is because the shaft is not mated to the gear. To mate it, select both the shaft and the gear and apply a lock mate. This keeps them locked together and the shaft will now turn the gears. The last step is to add the wheel to the output shaft. Browse to and insert the wheel part to the assembly. First, mate it concentrically with the output shaft. Then coincident mate the ring at the end of the shaft with the outside face of the wheel. The wheel is not mechanically mated to the shaft, so to make the wheel turn the shaft, we need to again add a lock mate. That's it for now. In this video, we've covered how to use advanced mechanical mates to simulate a working gearbox in Solidworks. Thanks for watching.